Okay, very good. Welcome everybody. Welcome to this webinar. I'm Alex Wallet and I'll be your host today. A few housekeeping items to get started with. This fine gentleman here is my partner here at SimWell, and he's going to be monitoring for us your questions. So feel free to ask any question at any time during the webinar, depending on the quantity and type of questions. John may interrupt and ask a question as we go, or wait until the end to ask the question that you have. So feel free to ask any question that comes to mind. It would be a pleasure to answer them as we can. And after the webinar, if you have more questions, feel free to reach me at this email address, and you can also find more quality content about simulation, optimization, anyLogistix, and SimWell at these two websites. So I'm Alex. I'm the founder and CEO of SimWell. I'm also a lecturer at two different universities here in Montreal, where I'm based, Polytechnic and ETS. I'm also an invited lecturer from professor or students in other universities. My background is industrial engineering, and I've done simulation my whole career. Started my own business in 2015, which is SimWell. SimWell, we're based in Montreal, Toronto, Chicago, and Pittsburgh. We cover the whole North America for simulation and anyLogistix. And I'm happy to be here today. We are your simulation technology partner, and we help you make confident decisions. So let's get started on the topic of today. So 3 key considerations when making supply chain or when supply chain modeling. So these are 3, in my opinion, aspect of a project that will either break or make your simulation or your supply chain project successful. So the model speed, the use of simulation, and don't bring your toolbox with you when supply chain modeling. So let's get started with model speed. So I hear a lot of these things nowadays by different kind of people. So things like modern computers are so fast nowadays. Model speed is not a problem anymore. Model design is not as important as it used to be. But this is all dead wrong. Why is it wrong? Well, this like a fast model will allow you to debug your model much faster. And this is a graph of the number of scenarios you can make in a week, like per day or in a week, if the model takes 1 hour to run versus 1 minute to run, right? Either if it's an optimization model or simulation model, doesn't matter. The faster it is to run, the more scenario you can make, right? So look at the blue one is if it takes an hour to run your model. This is like this tiny little blue bar at the bottom here. This is how much you can do. You have the data here. It's not complex mathematics, right? In a week there's 168 hours. So if you run 24 hours a day for 7 days, then you can do a maximum of 168 scenarios in a week. While if the model runs in a minute, well, it's 10,000 scenario in a week. So there's a huge difference in terms of debugging time, in terms of quality of the results, if you can run 10,000 scenario in a week versus 168. Now, so this is for 1 minute versus an hour. What if it's in 1 second? What if your model takes 1 second instead? Then in a week, you can run 600,000 scenarios. Do you think your results would be better if you can run 600,000 scenarios versus 168? It will be much better, right? And we're working with a partner, an AI partner nowadays, and this is not necessarily any logic. anyLogistix is more anyLogistix, but we're working on a model to train, building a model that we're going to be using to train AI. And our AI partner is thinking that we'll need 1 million run to train the AI, right? So at 600,000 max scenario in a week, if the model runs 1 second, then to get the million mark, it's almost 2 weeks, right? And if the model takes 2 seconds, then it's a month. If the model takes 3 seconds, right? And it goes like that. So very fast, very fast. The model runtime will impact the number of scenarios you can run. Either if you like AI stuff, obviously it needs a lot of run. Or even the supply chain model or network optimization model, the more you run scenarios, the better would be the results. And why is it important, right? So in optimization, when you compare optimization runs, if you run the optimization model once, you get an optimal solution. Yeah, but what if the best solution is not necessarily the optimal, but it's a close second, right? And then the more scenarios you can run, the more scenarios you can afford to run because the model is fast, then the more likely you are to find that close second scenario that is better than the optimal solution. And what's better than the optimal solution? Well, it's when there's some other qualitativeness or quantitative aspect to consider into the decision. One of things is the capital investment. So if the optimal solution requires a lot of capital investment, even if it brings the best net present value, it might not be the best choice. If there's a close second that requires much less capital investment, then that might be the solution that is decided. If a solution or a close second bring less disruption or improve labor relation, that's also a good reason to choose a close second rather than the optimal solution. And you cannot find that close second unless you are able to run several scenarios, and you are able to run several scenarios if the model is fast to run, or you can afford to run them if the model is fast to run. And in simulation overall, there's no magic optimization button that'll give you the best solution. So in simulation, in general, you get the best solution by testing a bunch of scenarios, and the more scenario you run, the better the solution, right? So in any case, having a fast model will allow you to get the model completed, verified, and validated faster because it runs faster, you can debug faster, and allow will give you better results because you can afford to run more scenarios. So, but the next question is, how do you build fast models? Well, there's no like secret sauce, or there's no one thing that you need to define. The overall, it's all about the model design, right? And this is our anyLogistix methodology. So when we build an anyLogistix model, this is the methodology that we use, the methodology that we follow. And this is a proven methodology that gives us success and allows us to design a model that will achieve the objective of being fast, and being precise and fast, or find the right compromise between speed and precision, right? So several aspects of it. First thing is define the objective and the goals, and then once that is done, then gather and understand the data. So where's the data coming from? Understand each of the field in the tables, what they mean, but also how they are calculated. That's quite important to understand how the data is calculated, and understanding that gives you a much better understanding of the supply chain. Obviously, part of this process is also to understand the supply chain itself, the nodes, and how things interact with each other. That's study geography, analyze the data, understand the whole thing. Then functional design specification part 2. So define the KPIs, the scenario to be tested, make sure everybody understands, involved in the modeling, understands in depth the supply chain. Then this is internal approval by myself inside our team, and then after all of that, design the model. So you don't design a model before you have the data. You don't design a model before you see the data. You understand the whole supply chain. You design a model only when you have a good understanding of all these aspects, and with that understanding, then you can define the right level of modeling and build a model that's going to be precise and fast. So overall, this methodology allows you to build the simplest model to answer a specific question. That's always what we want to do here at SimWell, and what you want to do in building your own supply chain model. So always build the simplest model to answer a specific question, so the model runs fast and you can afford to run a bunch of scenarios. Now, these are a few practical tricks that you can use to minimize runtime of your supply chain models. And in optimization, the key is the data aggregation. So there's several ways to aggregate the data. Like one, and this is just example, it's not a complete or a thorough list. It's just a few examples that you can keep in mind. But one aspect is to the product aggregation. So I'll give you two examples where product aggregation are totally different. So one of our best clients is a salt producer, and several years ago, even before ALX was existing, we built a supply chain optimization model for them, like from scratch, basically. And one of the part that was interesting, that part, one of the key aspect was the data aggregation to have a fast model. And then in their case, they produce de-icing salt, so the salt that goes on the road in the winter, and they have like bags, but the fact that the salt is a 10 kilogram bag or a 20 kilogram bag or a yellow bag or a blue bag, I mean, it doesn't really matter in terms of the supply chain. At the end of the day, they're moving tons of salt, and for that matter, we aggregated all the product together into one single product. It was a ton of salt, basically, right? So so that simplified the whole model and makes the model run much faster because we didn't lose precision, but we aggregated the data that we could. Another example where is a food producer project we've done recently, and then they have plants all across the country, but some of their plants produce specific product. For instance, one of their plants would produce like all the bio product would be produced by one single plant. So in that case, you cannot use the same product aggregation as we use for the salt producer, because in their case, that specific plant is producing these specific product, and these product cannot be produced nowhere else. So in that specific case, we cannot aggregate the product. So be careful with that. This is, yes, speed is important, but not at the cost of precision, key precision in your model. So another one is the geography. So especially about the demand. So you can aggregate the demand through a postal code, for instance, or the first X digit, 3-digit, 4-digit, depending on how precise you need to be. Or another one that I've seen is aggregate the demand in the biggest city higher than X amount of citizens in a specific area. So and there's many other ways to approach this, but these are a few examples of how you can do that. Another one is the size of customers. So obviously, if you have big customers that are representing a large chunk of your volume, then you may want to keep them inside your model as is. So keep them like the Pareto percentage. So the 20% customer that are representing 80% of the volume, you may want to keep them as is in the model, not aggregate them necessarily, and everybody else, all the small clients, you can aggregate kind of thinking. Simplify the fleet if you can, and the decision that you make here, you can review once the model, when you click play the first time and see the run speed. If the model run fast, then you can potentially afford to deaggregate the data and be more precise, depending on specific cases. And if the model is running way too slow, then you may have to go back and aggregate some of the data. So this is not necessarily an exact science. It depends on every single project, but that's certainly things to keep in mind and practical tools or things to consider when you do that. But at the end of the day, I can summarize all this by always build the simplest model to answer a specific question. So that was for optimization. Now, what about simulation? So simulation, there's well, these are very technical example, not necessarily 100% any logistics oriented. It could be any logic oriented. It could be any other package oriented. This is overall what I teach my students in university when I teach simulation. But yeah, a few examples. So overall, to minimize the simulation runtime, you want to minimize the number of events in a simulation model. So especially like discrete event simulation, event agent-based modeling is, at the end of the day, it's kind of events occurring, right? So if you minimize the number of events, you would minimize the runtime. There's direct link in between the two. So some potential solutions. So pre-calculate everything that can be outside of the simulation model. For instance, if you're modeling a plant and then an employee moves from point A to point B all the time, then instead of having speed and distance for that specific movement and calculating speed times distance all the time for that specific movement, instead you can pre-calculate that, the time that it takes to move from point A to point B, and just model that route, that move as a simple delay, right? As a simple time. So you avoid a bunch of calculation and the model runs faster. Another one is data-driven model. So use matrix instead of queries. So if you have a matrix of data, let's say 1,000 row, 1,000 column, and you're interested about the specific like row 50, column 50, then if you have it in the matrix format, you just call like, this is the matrix, row 50, column 50, here is my data, right? And so that's very fast, that's very effective, much more effective than having a query, for instance, or having a loop that's searching for something in a data table, or even logic like if, then else, then whatever. So that's much more expensive in terms of simulation runtime and computing power than it is to pick a specific value in a matrix. So whenever you can, build your data as matrix. Another one is try to build your model event-based and not time-based. So a lot of time when this is the problem when simulation models are very slow, is someone will have a loop every second checking for something, right? And that's very expensive because every second there's event, and if you have several loops like that check something every second or every minute, then you have a lot of processing power that is used for nothing, right? So when event-based is these loops, they check for something, right? They check for or tank level, or they check for a specific event or number of people in queue. So instead of having a loop like checking that, what you can do is just have, okay, the entity enters the queue and is more than 5, and more than 5, then boom, you trigger that event in that specific time. So that's much more efficient in terms of processing time for computer than it is to have the loop, essentially. Other things, and I'll move a little faster on these ones. So disable any output that are not essential. Disable animation, of course, and minimize communication to the outside world. So sometimes I see people are communicating outside of the model itself to some kind of a code, a Python code or Java code that is outside of any logic, or any code that is outside of any logic. If that code is simple enough, then just do it inside the simulation model. Replicate it inside a simulation model instead, and that's going to run much faster. So that was the very technical part of the presentation. We'll move back up a bit and start go back to talking business. That being said, the conclusion here is always the same, right? Always build the simplest model to answer a specific question. Always build the simplest model to answer a specific question, and that's how you're going to have fast models. So that was the first of the key 3 points to consider, what will make or break your supply chain project. The second one is simulation, right? Like this is a slide I use in all my simulation presentation. And here we're not necessarily in the simulation presentation, we're like anyLogistix, supply chain optimization simulation, like supply chain modeling, right? But this, like someone contact us, they're interested about simulation. This is one of the first slides I showed to them. And this is for us is a gate, right? Do our solution or will our solution help the client solve their problem? Like, and these four things are usually necessary for a simulation project, right? Is the system complex enough? Like, there's no mathematical solution that is existing. Excel is not enough anymore. It's not capturing the real world complexity, variability, and system interaction. And the system is just too complex. Or investments are important. Decisions are strategic. Usually these two comes together, and we need to convince decision makers. And 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 I'm thinking about this slide, right, in a supply chain context, and all the supply chain modeling discussion that I have in my career so far, every single one of them is a complex. Like, a supply chain by itself is a complex system, and you change something in your supply chain, well, that's going to cost quite a bit of money, and for sure it's going to be strategic, right? The supply chain is becoming more and more strategic for organization. And the last one, need to convince decision maker, don't mess with my supply chain, right? Like, yeah, you have this great idea, thank you, but I don't want to risk implementing it in real life. And that's where simulation becomes real handy in simulating the impact of a decision or proposed decision on the supply chain, and help convincing decision makers. So supply chain are getting more and more complex. There's more and more variability in supply chain. Variability is like demand fluctuation, cycle time fluctuation, route time fluctuation, time for overseas shipments, things like that. And there's more and more risk events. Like, obviously the pandemic is a good one, but another one is like, we have a client in Louisiana. They've been hit twice by hurricane this season. So that really doesn't help for supply chain. There's more and more of these risk events around the world, like forest fire, weather events, big snowstorm we have here in Canada, and things like that, right? So when we only use optimization in a supply chain project, it's the happy path, right? It's living in a world of rainbow and unicorn, and not taking into consideration any of the real world complexity, variability, and the risk event. So please, when you do supply chain modeling, please include simulation as part of the project, and stop being in the happy path and living in a world of rainbow and unicorn, and start doing simulation to really capture these variability and risk event of the real world. That cannot be captured at all with the optimization. So one of the topic that is getting more and more important these days, or trigger more and more interest by supply chain analysts and decision makers these days, supply chain resilience, right? And doing some research on the subject, I found this very interesting table took from this specific article here, and I recommend you to go and read that after this webinar when you get a chance. And I thought it was very interesting. So 8 categories of resilience-oriented investment. And you have the 8 categories here. But what is very interesting is, out of these 8 categories, supply chain or anyLogistix can be, supply chain modeling and anyLogistix can be used for 5 of them, right? So the first one is gathering more data. Second one is investment in improving the quantity, speed, and quality of information. And that's, in my mind, that's a supply chain digital twin, right? The quality of information. So if there is an event or whatever happened, and you have your supply chain digital twin connected live with your real world data, then you can use your supply chain digital twin to start testing a bunch of what if in that digital twin, and that will generate quantity, quality, and speed of the information that will allow you to take better decisions. The second one, like supply chain design, that's a classic for ALX, right? And that's network optimization inside the ALX and up simulation, right? If we want to move away from the happy path, and then to me, doing a network optimization should always come with a simulation. And you shouldn't do one just one of the other. It should always come together. The next one is buffers, right? Creation of excess cushion in the form of inventory capacity and lead time. But yeah, that's interesting, right? But the main question to me is how much, right? How much buffer do I need to put to have a resilient supply chain, and where should I put it, and how much is going to cost to add these buffer, right? And then through simulation, you can test the impact of having these buffer. And it's not network optimization, it's simulation. When we're talking about inventory and sizing the right level of inventory, that's simulation, because if you don't capture the variability, the day-to-day variability in the demand, in the truck lead time and things like that, then you're not capturing the real-world variability and real-world fluctuation. And that's what inventory is for at the end of the day. So simulation is the key to answering these buffer questions and how much and where. The next one, operating flexibility. So if there's changes happening in the flows or you can change the flow or the product specification themselves, that's again the supply chain digital twin to answer what to do, what if scenarios, testing all these in a virtual environment before taking a decision in the real world. And finally, last one, preparedness. So designing contingency plan for possible supply chain shocks and testing of plan, right? That's simulation as well. There's no like, are you gonna test it in your real supply chain? I mean, that's what simulation is for, and we call it serious. That specific scenario we call it serious gaming here at SimWell. So if you have your mall built in anyLogistix, then you can serious gaming with it and prepare your plan and train your team and be ready for the next disruption. Your people, your team would have the right mindset and will be ready to implement any or the best solutions that you already identify ahead of time. Very good for that. So, and what's make anyLogistix so unique on the market right now is the ability to convert an optimization scenario into a simulation. So this is like a picture of anyLogistix for the right, and then we have a network optimization run, and then we run a few tests, a few results, and then you right click on these results, and then you convert to a simulation scenario, and then you build a simulation. All that in one single package, right? You have network optimization, you have simulation, all in one single package. You have the state-of-the-art optimization engine that is Cplex, and a state-of-the-art simulation engine that is anyLogic. All that in the same package, and you can switch from a network optimization to a simulation, or from a simulation to a network optimization by one click of a button. Obviously, there's a little bit some difference in data that is required on both sides, but any work that you do in defining your supply chain optimization model can be used, will be reused for your simulation model and vice versa. So that's what makes anyLogistix so unique, and that's what makes it the perfect platform for supply chain model. So that was the second part of the key 3 things that you need to consider what will make or break your simulation, your supply chain project. First one was model runtime, like model speed. Second one is use simulation, because if you don't use simulation, you're losing a lot of the information that is required to really optimize your supply chain. The last one of the 3 is bring your toolbox. Right? Is everything you've learned so far, you're not taking that and throwing to the garbage. You're the sum of your efforts so far in your career. So everything that you've learned so far will be useful in ALX. So bring your toolbox. The first toolbox is between your 2 ears here in your mind is your modeling mind. So if you're an experienced modeler, you don't throw that away, right? Everything that you've learned so far in other package, in Excel or whatever, will be useful in ALX. And here's one example. And so there's no such thing as a tool that can do or can cover all potential real world options, right? Then there's tons of real world problems, and there's no tool that can, like, in the drop down list there would be 1,000 options, right? It would be way too complex to have all the potential options in drop down list. So when you're modeling in ALX, you need to stay creative and bring your modeling mind with you. So this is a question that I had before. So how do you model that ice cream cannot be moved in the same truck as milk in a supply chain, for instance? So there's no such thing as a table that says in this specific vehicle type, here are the product that you can put, or here are the product that you cannot put in. There's no such thing in ALX right now. But does that mean I cannot model the fact that we cannot put ice cream in milk in the same truck? No, not at all. There are workaround, but I don't like the word workaround for that. I think I think a hack would be a better word, or just using your modeling mind to find solutions. So how do you do that? Well, you create two custom vehicle, truck ice cream, truck milk. You create two custom units, truck ice cream unit, truck milk unit, and then you put your vehicle type capacity in these units. You convert these units into you create a conversion rules in the conversion table, and then with that you can model, with that hack you can model the fact that like ice cream cannot be in the same truck as milk. And thanks to Daria from ALX Tech Support for that one. By the way, this technical support at anyLogix and anyLogistix is great. Contact them as you need. You can also, if you're in North America, feel free to contact SimWell as well. They'll be pleased to help you. You're not on your own out there trying to figure out how anyLogistix work. There's great technical support. Feel free to use it. It's just one example. Another example that is not here is like a few weeks ago, one of our clients in the automotive industry wanted to model the fact that shipping, the last mile logistics of a pickup truck and a sedan is not the same. But he doesn't want it to go in a lot of details and whatever. He just wanted to have a fixed cost for the pickup and a fixed cost for the sedan to ship for the last mile logistics. So there's no such an option of a cost per product type in ALX. This is pretty rare option. Oh no, we cannot model that. No, well, we can model that, right? It's just using what's there and find the right way to model it. And the solution in that specific case is similar to this one, creating different vehicle type, a vehicle type truck moving a pickup, and a vehicle type truck moving a sedan, and then have a different cost per unit for these two. And here you go, right? So that's that. All these examples are modeling examples. So keep your mind open, be creative, and don't forget about everything you learn about modeling, because modeling is using the tools that you have to achieve the objective that you wish to achieve. Right? So bring your modeling brain at work when you do supply chain modeling. Second tool that you need to bring, or that you can bring, actually you don't necessarily need to bring Excel, but you can bring Excel when you work with anyLogistix. Or if you're an advanced user of Excel and you're in love with Excel and you dream Excel, well, even if you don't dream Excel every night, then you can use Excel, part of your ALX supply chain modeling project. So first thing is you can, like you see, you can export scenario to Excel. So you have a network optimization. Here you right click on it and then export scenario. And that brings you to an Excel spreadsheet and warn you, like, sensitive souls beware, this ugly content warning is coming, right? That's the result. that's your Excel export. And well, obviously there's no formatting. It's pretty ugly. The anybody that knows me would know I hate grid lines like that. Is oh, I cannot see grid lines anymore. And then the columns are not the right side, and there's all the tab are listed in specific like in the alphabetical order. So and more, right? But hey, there's nothing that prevents you to format that export, right? And there's a lot of things you can do in that export. You can format the headers. You can add columns, right? Don't be afraid of adding extra columns into that table. Obviously, these columns, when you re-import the that Excel spreadsheet back into ALX, that column would just be ignored. So so feel free to add, like here I add notes and whatever notes. It could be documentation, could be calculation. You can even have formulas like this 5 here could be 5,000 divided by 1,000 gives 5. And you could have other formulas here that are used to generate these tables. You can have conditional formatting like this. You could have, you can change the color of the tab, obviously. You can rearrange all the tabs so they're not in alphabetical order anymore. And I kind of group them into like in logical way, anything related to customer, anything related to supply chain nodes, anything related to transportation cost. And that way the data is much like the Excel data for it is much more intuitive, easier to manage. And then you can play with that, make modification in Excel, re-import that into ALX, and you have a brand new scenario. So so that's, you're not forced, like you don't have to use Excel necessarily in your ALX project. But if you want to use Excel, then hey, you can do that. And with the data, you can play with the data that's feeding ALX in Excel, no problem. Next one, automating data crunching. So if you want to build a digital twin of your supply chain, you will need to automate the data crunching. So that's going to be a key of that supply chain. Is several tools out there that can help you do that. This is just some example. Azure Data Factory, Alteryx Time is examples or tools that we've come across. I'm not too familiar with these tools myself. It's my unfortunately my role move away from modeling most of the time now, and it's my teammates that have the pleasure and the joy of playing with these nice tools. And now at SimWell, but yeah, that's going to be part, automating the data crunching is going to be part of your process of building a supply chain digital twin in anyLogistix. And the last one, business intelligence. So so in ALX, like this is the supply chain optimization results, and then all here contains all the results that are generated by the supply chain. You can right click on this, export to Excel. And then another ugly content warning, sensitive things solves, beware, is this is the results, right? And but despite the fact that it's not very good looking, right? This is very cool. And why it's very cool is that the format is standard. And beauty of the standard format of output is that you can import that in a BI, business intelligence tool, whether it's Power BI or Tableau, any of your favorite BI tool. Then in this BI tool, you can build any graphs, visualize your data in any way you want. And my personal favorite is the Sankey diagram. And that's an ideal, in my point of view, diagram to represent the flows between supply chain nodes. And here's an example, like flow between suppliers to different ports, like supplier overseas, obviously, to different port to different DCs or direct to customer, and then from DC to customer. And then that way you can see the really, like in an like instant, you can point out or learn things about your supply chain. Like here we have only one supplier. That seems like a risk, right? In supply chain resiliency, maybe we could have a second supplier. Another one is like you look at the, like most of the flow is going to the port of of New York, right, on the East Coast. And if you're building a resilient supply chain, maybe we should consider adding another port on the coast, sorry, giving the volume that's going to the port of New York. So that could be a risk in terms of supply chain resiliency. So why not consider the port of Montreal, right? Since I'm based in Montreal, and then you can analyze and you can see the flow of your supply chain very well in the Sankey diagram. That's the beauty of connecting your anyLogistix results with a BI tool, is you have access to a bunch of other graph in that BI tool. There's obviously tools inside ALX that can help you visualize and analyze your output. But at the end of the day, I mean, there's these tools, these BI tools, they are designed in a way to show your data in different kind of formats to help you analyze them. So why not using these tools for that? And plus, they're usually not that expensive as well. So in conclusion, the three key considerations when supply chain modeling: one, simulation. Model run time, whether it's optimization or simulation. Having a fast model will allow you to reduce the time to results, so reduce the time to build a model, because you're going to be able to debug faster and verify, validate your model faster. And then because you have a fast model, you'll be able to run more scenarios, and by running more scenarios, you get a better solution at the end of the day. The second one is simulation. Like, I don't see, there's no, well, in the world we live today with variability and risk event, there's no reason not to use simulation when you model your supply chain. I mean, that's a must. It's a shame not to use simulation, especially in ALX. Well, the tool is there, and then you can easily switch from a network optimization to a simulation and back and forth. And the last one, don't leave your toolbox in the locker room. Bring it with you. You'll need it in the supply chain model. So that completes our presentation. So how do you work with us, anyLogistix and SimWell? So call us, schedule a meeting with us, talk to us about your unique challenge you face. We'll help you select the right technology, either if it's optimization or simulation or the best software, if your project is more anyLogistix or anyLogistix, and it will help you at the end of the day make confident business decision inside your business. More information about us, so you can contact me at awallet@simwell.io if you have any question following up this webinar, and anyLogistix website. And if you're not in North America, then you can find your local partner at this link on the anyLogistix website. Now we'll take questions.
Awesome, thank you, Alex. That was fantastic. Some great information from one of the. I know you have built hundreds of models in your career, and you can tell this comes from a lot of experience. So there are a lot of great questions. We tried to answer them through the webinar. If we haven't, we'll gotten to yours. We will address it afterwards. There's a couple that I've pulled out or that I've seen that we'll ask. So one is one of the big benefits of anyLogistix is being able to do the different types of experiments within it. So can you talk about the relationship in the data between the different experiments? For example, the data that you need for network optimization and then going to a simulation?
Yeah, thanks, John. Thanks for the question. Yes, well, any data that you input in either network optimization or simulation will be directly reused in the other type of experiments. So, for instance, the data that is constant between technology, whether it's optimization or simulation, would be all your nodes, right? Your supply chain nodes, like where they are located, the cost, the holding cost, the facility cost, things like that. So these are constant, whether it's optimization or simulation, and you don't have to redo it, re-input it, whatever, because it's all in one package. And but some of the data you may have to rework a bit. Like at the beginning of the webinar, we discussed aggregation of data to reduce the optimization time of your models. So if you aggregate your data, your demand monthly, for instance, you have like monthly period in your optimization model, then obviously that specific data will need to be deaggregate for the simulation model to be at the more micro level that the simulation model needs. So it's not like just the click of a button, but most or a big chunk of the data that you use, a big chunk of the work that you've done to build either your simulation or your optimization model will be automatically reused and automatically transferred into your optimization and simulation model.
Awesome. Thank you, Alex. You had mentioned that you always build the simplest model to solve a problem a few times, and I think that's pretty simple advice, but not everyone realizes it. So what in your career have you seen that went wrong when a team doesn't take that advice or when they overmodel?
Yeah, that's that's a good question. But the impact, like a slow model will always, like in my career, I've always, like it's always the same. The slow model always lead to a less successful project because you simply cannot afford to run as many scenarios at the end of the day. So the faster the model runs, the faster it is to build them all, verify and validate them all, and that verification validation is the most uncertain phase of a supply chain modeling project, right? Because you can build them all, and then the first run is oh no, we're not getting the base case or something like that, right? So like until you get the base case right, and this is verification and validation. So if your model takes an hour to run, and well, then you make a change, you run it an hour later, you get the results. I mean, that's a very long time. If you have 8 hours in a day, then you can afford to make only 8 different changes. And if you screw up, you change the wrong thing or something, then just find out an hour later. That's very costly in terms of duration and calendar time of a project. So for that specific reason, if it takes a minute, then you can afford to run way more, and then verification, validation phase of project will be much more shorter. So you get to results faster and you get better results. So yeah, it's a simple advice, but in my point of view, and that's why I was the first one on there. It's one of the key one, but not one of the key one, but also one of the aspect that I see a lot of people not considering at all, or not even thinking about run time of the model, or worse, blaming the software, right? And while it's in my experience, it's never a software problem. It's always a model design problem, and your model design will have a direct impact. It's your model design that will have the most impact on your simulation and optimization runtime. So forget about the software is slow, whatever. That's not the problem. The problem is always the model design.
Awesome. We have a lot of really good questions coming in, so we're going to try to get through these. A quick follow-up on that is, how do you you have a team now, a large team of modelers. How do you make sure that they get the right design? Like, how do you build that team or start that process? Not just for you, but for any organization that is building this team.
Oh yeah, that's a challenge, and but that all comes from our organization of the work. I'm going back to this slide here just to show you. So whoops, there you go. So this part here, right? This is something we didn't. Whoops, sorry. I'm misclicking. There you go. So this part here is something we added over time, right? And it's now before the model design even start. needs to approve that. And usually also we don't send our junior people designing the model. Like in part of this process here, we have an experienced modeler part of the process, because the key of being successful in a simulation project is here. And most like supply chain project, I say simulation, that's because my world is simulation. But the whole success of a project is often defined in the first few weeks in this design part of it. And part of that design is to have an experienced modeler in the team. That's something actually we can help you with, because our business model at SimWell is to do two things, right? We are a consultant. We build models from scratch. We can do that for you, but we also distribute the software. And part of our job to distribute the software is to guide you, help you, support you in being successful with a project. And we recommend in it with every purchase of ALX, we recommend a few hours, few days, depending on what's needed, of coaching to really be part of your team, being that experienced modeler that I am, or my colleague Andre, or my colleague Alex Franco is in our own team, playing that role in your team when you're getting started with supply chain modeling.
Awesome. Thank you, Alex. So another great question from Gennaro is, based on your experience, what is usually a good balance between data analysis and model deployment in terms of project time?
Well, it always depends on the cases, but the rule of thumb that we have is that there's like 1/3 of the project is understanding the supply chain, understanding the data, gathering the data, analyzing the data. 1/3 is building the model itself, and 1/3 is generating the results, analyzing the results, building a report, making a presentation, and so on. Now, obviously, that proportion change, but each of these phases are as important as like are all as important. And so, like, sometimes we focus a lot on the model building part of it, especially if you come to like anyLogistix training. We'll focus a lot on the software. We'll teach you how to use software, right? But this should be the simple part of the supply chain modeling project, where especially in anyLogistix, because the framework, the models are already built in anyLogistix. So that should be the easy part. The most complex part are the other two, like the analyzing data, crunching the data, and analyzing the results, crunching the results, presenting the results. And
awesome.
Yeah, I hope it answered your question.
Awesome. Another great question came in from Jaya Krishna about how is this different from a specific simulation tool? So, but in general, SimWell is a team that specializes in simulation and optimization. So how does anyLogistix differ from just a standard simulation tool, or even a standard optimization tool?
Yeah, that's a good question. The main difference is that in anyLogistix already provide the framework, and the models, like the optimization models and the simulation models, are already built inside the tool. So you're not building, like, drag and dropping and then creating a simulation model or an optimization model inside, or programming an optimization model inside ALX. That work is already done for you. So you feed it with the data, you use a framework, and that saves a lot of time in building the model. So you can concentrate more on the data part, on the results part, and less on the modeling part, because the model is already built. On the other side of that, for anyLogistix, for instance, you open anyLogistix, you have a blank page, right? And on the left, you have your palette of modeling tools that you can use to build your model. You can build your whole supply chain model in anyLogistix if you want, but the folks at anyLogistix, or the consultant at anyLogistix, they've done so many in the past. They've done so many supply chain models in anyLogistix. They said, well, we're doing all these projects in anyLogistix, and we build a supply chain model from scratch every time, more or less. So they decided to make it a product, and that's where our ALX was born, in a way. So So ALX is more of an end user package. anyLogix is a pure modeling package where you start your model from scratch. So
Excellent.
if you have to build a supply chain model or analyze a supply chain, well, you already have the model built in ALX, so that's the perfect tool to do that.
Awesome. Thank you, Alex. So I think the last question and I'll take this one, is can we get access to the recording in the slideshow? So yes, you can, and as long as you're registered, which you obviously are, you will get an email with the recording and the presentations probably next week, maybe this week, but most likely early next week. So you'll get everything from here. And then I guess, Alex, one more question for you is, if someone wants to work with anyLogistix or they want to talk to SimWell about how to work with these tools, how can they get into contact with you?
Yeah, sure. Here it is. That's my email address. Feel free to contact me at that address. SimWell.io. Whoops, here it is. Here you even have my phone number. If you prefer, you can call me directly. My email address. And like obviously SimWell.io. There's blogs and interesting information there. There's a ton of resources on the anyLogistix website. And if you're outside North America, you can find your partner here.
Awesome. Thank you, Alex. So thank you for everyone for joining this webinar. We hope it was of value to you, and don't hesitate to reach out. Have a fantastic day.
Have a good day, everybody. Bye-bye.